Welcome to Pioneering Personalized User Experiences at StockX with Amazon Personalize. My name is James Jory. I'm an Applied AI Solutions Architect with AWS, and I'm pleased to be joined by Blaine Dietrich, a Machine Learning Engineer with StockX. The points that we'll cover in this session will include a look at the current state of personalization and opportunities for personalization in online retail, an overview of Amazon Personalize and how it works, a rundown of some of the key features of Amazon Personalize and how to map them to retail use cases. Then I'll present a demo of how to apply these features in a sample e-commerce application. Finally, we'll be spending the bulk of the session hearing from Blaine on StockX's journey with Personalize in production. Personalization has become ubiquitous and is baked into nearly every product, service, and device that we use every day. Technology, and specifically data and machine learning, have unlocked the ability for brands to better understand the interests of their customers and to deliver hyper-personalized experiences in real time. However, customers have become accustomed to these experiences and now see personalization as a standard level of service. The bottom line is that personalization, or more precisely, effective personalization, is no longer optional, but a requirement for success in online retail. So what are some of the core use cases of personalization in retail? Personalization typically starts on your homepage, where you get that critical initial opportunity to make your customers feel more connected to your brand. Recommending products and categories that align with your customers' interests is a great way to accomplish that goal. From there, you can help your customers refine their product selection through similar item recommendations on your product detail pages. And in situations where you're taking predefined lists of products, such as on your category pages, you can personalize the order of those products so that the most relevant products are sorted to the top of the page for each user. And finally, as your customers increasingly expect connected experiences across all the touch points with your brand, extending personalization across your applications and your communications channels will keep your customers engaged when, where, and how they prefer. So with some of these use cases and opportunities defined, let's take a closer look at how Amazon Personalize works. You start by providing data about your users and items to personalize. The types of data that Personalize models on is of three types. The first is the activity of your users, also known as events. Examples include products your users are clicking on, adding to their carts, or purchasing. Now, it's important to note that Personalize is industry agnostic, so the events you choose to send to Personalize should be specific to your industry and your application. This dataset type has the strongest signal for personalization and is the only one required by Personalize. The second dataset type includes data about your items. For example, their category, color, inventory status, essentially all the information you already have in your catalog. This dataset type is optional, but is particularly valuable in cases where we're cold starting recommendations for new items. The third dataset type includes details about your users. For example, their age, location, or subscription tier. Essentially anything that helps Personalize better understand the interaction data. Once you have your datasets defined, it's time to get them set up and imported into Personalize. You can import your historical data into Personalize using import jobs. You can also stream events, users, and items into the service using the Personalize API. Once your data is in Personalize, you can create custom private models trained and hosted for you in just a few clicks. Behind the scenes, Personalize is performing all the steps you typically see in a machine learning pipeline. Now let's review some of the killer features of Personalize and how they can be applied to retail use cases. Modeling on impression data allows you to leverage items that have been seen but not clicked on to improve the relevance of product recommendations. Item exploration, where you can balance how much to explore, that is, recommending items with less interaction data or relevance, against how much to exploit, where we're recommending items based on what we know of users' interest. Filtering allows you to include or exclude items based on business rules that you define. So this allows you to implement common e-commerce use cases, such as excluding recently purchased items from being recommended again or items that are currently out of stock. Cold starting users and items allows us to make recommendations for new users and new items that we don't have any interaction history for. This is particularly useful if you have a rapidly changing catalog or a rapidly growing user base. Now I'd like to show you a quick demo of how you can implement some of these personalized features in a sample e-commerce application. You can find the full source code for this demo on GitHub under AWS Samples and then Retail Demo Store. The Retail Demo Store is a sample full-stack web application that implements the core use cases supported by Amazon Personalize. The application also streams interactions from the storefront to a personalized event tracker to support real-time recommendations and recommendations for new or cold users. Finally, a personalized filter is used to exclude recently purchased products so they're not recommended again to the same user. There are about 55 products across 7 categories that are preloaded into the system, so the catalog size here is pretty small. However, there are also 6,000 fictitious shoppers loaded into the system, and for those shoppers, about 500,000 historical interactions are generated that are used to train the models in Personalize. Switching over to the Personalize console in the AWS account behind this demo, we see there are 3 personalized campaigns, one for each of the core use cases. So we have a campaign for personalized ranking, product personalization, and related products. Let's head back to the storefront and see how each of these campaigns is used for different user experiences. Now, once you create an account in the Retail Demo Store, you can access one of those 6,000 shoppers from the profile page. And you can see that each shopper has an associated persona identified by 3 categories of interest. So for Joseph Maddox, he's primarily interested in products from electronics, then apparel, then accessories. Now, it's important to note that this persona is only used to generate the historical interactions. Once the models are trained and personalized based on those interactions, Personalize takes over and makes recommendations based on the models. Selecting one of the shoppers and saving our changes allows us to emulate that shopper in the storefront. So we see we are now emulating Joseph in the storefront. On the homepage, the first use case is implemented in the Inspired by Your Shopping Trends section. Now in this section, we are displaying personalized recommendations based on the current user's interests. So the products here align with Joseph's interests in electronics, apparel, and accessories, where we see products from electronics, accessories, and apparel. Now in cases where the Retail Demo Store is making recommendations based on a personalized campaign, we also display the personalized recipe behind that campaign so you have a sense of what algorithm is being used. In this case, we're using the AWS user personalization recipe. Clicking on one of these products takes us to the second use case. The product detail page is using the AWS SIMS recipe to recommend similar products based on user behavior across the entire site for users who also interacted with this particular product. The third use case is implemented on the category pages. So for the featured products, we're taking the list of products in the database marked as featured and sending those products to the personalized ranking campaign to re-rank or reorder the products based on the current user's interests. So again, based on Joseph's interest, we're seeing products from the accessories, electronics, and apparel sorted to the top of the page ahead of products from other categories. This use case is also implemented in the search component. We're taking the results from an Elasticsearch query and sending those to personalized ranking to re-rank the search results based on the current user. So we see for Joseph, we have the backpack, headphones, and the fitness tracker ahead of products, say, from the housewares category down here. Now to see how the recommendations change for a different shopper, let's go ahead and select a different profile. So Lynn Thompson has a persona where she's interested in jewelry, footwear, and beauty. Let's head to the storefront and see how the recommendations change. So on the homepage, in the Inspired by Your Shopping Trends, we see recommendations from the jewelry category, the footwear category, as well as the beauty category. Clicking on one of these products takes us to the product detail page where we get similar item recommendations. And then on featured products, we see products from the beauty, jewelry, and footwear categories ahead of products from other categories. And finally, in the search component, the same query for the letter T sorts products from the jewelry category and the footwear category ahead of products, say, from the accessories category. The next feature I'd like to demonstrate is how the filters work to exclude purchased products from recommendations. So to simulate that, we'll go ahead and purchase this pair of earrings, add them to our cart, check out. Now what's happening behind the scenes is that the retail demo store is sending a order completed event to the Personalize event tracker to indicate that this user has purchased this product. This ties into a filter in Personalize that is set up to exclude products where the user has an order completed event in their interaction history. Heading back to the storefront, we'll see how this particular product is now being filtered from results. So in the inspired by your shopping trends, we do not see those earrings being recommended. And on the featured products page, those earrings are no longer being displayed as well. The final integration that I'd like to demonstrate is the cold user recommendations. So to simulate this, I'm opening an incognito window. So I'm simulating a brand new session to the storefront. So this is a brand new user that's never used the site. And we can see that I'm not signed in as a user, so I'm an anonymous user at this point. And if we go down to the inspired by your shopping trends, we see that it's now trending products. And the reason for this is because we don't have any interaction history for this user. And so Personalize is going to recommend popular products. So these recommendations are based on popularity across the entire site, which is a great default behavior. Now, once I start interacting with some products, let's say we're interested in some footwear, we'll see how the recommendations change. So I'll click on a few different footwear products. Now let's head back to the storefront and see how the recommendations are different. Now we see that the section is inspired by your shopping trends, and we're having recommendations from the footwear category as well as some other categories. So you can see how Personalize adapts to recommendations in real time, even for cold users. I hope this gave you a quick sense of how you can put Personalize to work in a retail application setting. You can deploy this project from GitHub. It's located under AWS samples, under Retail Demo Store. You can deploy this into your AWS account and interact with this application just as I've shown here. So I hope this gave you a quick sense of how some of the key features of Personalize can be implemented in an e-commerce application. Now I'd like to turn things over to Blaine so we can hear about StockX's journey with Personalize in production. Blaine, take it away.
Thank you, James. My name is Blaine Dietrich, and I'm a machine learning engineer at StockX. StockX is a Detroit-based online resale marketplace for sneakers, apparel, accessories, collectibles, and electronics. Unlike other platforms, there's a single product page for any given product that StockX curates, and we sell these products in a bid and ask fashion. So when a bid and an ask match, we transact a sale between those two users. Our platform is powered by real-time data so that users know that they are transacting based on the fair market value of the item. We inspect all products, and they are verified authentic by StockX, so a user doesn't have to worry about receiving a fake or a damaged product. The StockX machine learning team has several team objectives related to personalization that align with the reasons we chose to use Amazon Personalize. Providing personalized recommendations is one of the best tools we have to help increase user curiosity and discoverability of new products. We currently offer a personalized home screen to users that has product collections like the recently viewed products and products recommended for them. This personalized content is one of our techniques to encourage users to make bids and asks, which drives conversion. Many of our products are dropped in an unscheduled release, and as a result, our traffic is concentrated into small windows. The traffic to our services during these drops can easily spike to 4 or 5 times the normal volume. Another side effect of these unscheduled releases is that our machine learning models need to be adaptive and need to gracefully handle receiving products that they didn't train on and do not know about. At the beginning of 2019, we were mainly focused on growing our marketplace and user base through helping users discover new products. There were no machine learning powered features at StockX at the time, so every user had the same static experience. Most users were focused on visiting StockX for a specific product, which they would bid on and then leave. We saw an opportunity here to increase customer engagement by keeping users around for a longer session where they ultimately bid on more products. After implementing Amazon Personalize, we had a personalized experience for every user on our home screen, and they would even see this update over time. This broadened product discovery and helped users find products that they loved but previously didn't know about. This also showed us an example of why adding a machine learning powered feature to StockX was such a good idea and helped establish a precedent for prioritizing these machine learning features in 2020. But let's take a look at how we got here. So data is an important component to successfully creating personalized experiences in any business, but particularly in a unique one like StockX. StockX has multiple top-level product categories. They are sneakers, streetwear, handbags, watches, and collectibles/electronics. Each of these categories has their own home screen. And one of the requirements when we were designing the recommended for you experience with Amazon Personalize was to only show recommended products for that associated home screen. Whenever a user interacts with our platform on these home screens or any other screen, we collect data based on how that user is interacting with our platform. Example events that are emitted are things like product page views, product tile clicks, or even the bids and asks themselves. Our front-end clients emit user interactions to a shared analytics API, and this API compiles these interactions into a data warehouse. A Python ETL tool is then used to wrangle the data from this data warehouse. So let's see how this is done. This diagram shows our overall process for batch ingesting user interactions data and storing it in S3 in the format that Personalize expects. On the left are our front-end clients sending their interactions data to our analytics data warehouse. This warehouse is used by many teams across the company, so we could not just simply change the schema for direct ingestion by Personalize. Our Python ETL tool consists of 3 parts: the analytics data fetcher, which performs SQL queries on the data warehouse and passes the results along to the interactions dataset builder. This dataset builder reads in that data as well as a YAML configuration file that it uses to determine what fields to filter on. The resulting dataset is stored in S3. The schema builder reads in the same YAML configuration file and outputs a personalized schema JSON file to S3. This ETL tool is the first step in our personalized offline training pipeline, and we trigger it once a day. Once the batch interactions dataset and interaction schema are in S3, they can be used by the dataset import job. Once the dataset import job finishes, we now have our interactions data in a personalized dataset. So here's an architecture diagram showing how we create one portion of the Amazon Personalized infrastructure needed for the recommended for you experience. Note that this is specific to the sneakers product category, and this infrastructure is replicated 4 more times for our other top-level product categories. The leftmost box shows the datasets and dataset schema that were output from our Python ETL tool and uploaded to S3. Each white box marked with the Scala logo is a Scala class that utilizes a portion of the Personalize Java SDK. The Personalize adapter object at the top contains references to all of these managers and orchestrates the entire workflow. In order, these managers first create the dataset group and schema, then the dataset import job and resulting dataset, the solution and solution version, and finally the campaign. Training the solution version is the longest running step of our pipeline. It takes around 6 to 8 hours for our largest dataset, which is sneakers. And all of our managers, including the solution version manager, will query for their job status until it's complete before moving on to the next step. So data ingestion and personalized infrastructure creation are not the only components used to serve the recommended for you experience. Here's a diagram showing how we use an AWS Lambda that communicates with our Amazon Personalize campaign to give recommendations to our users. It's a relatively simple Lambda that takes in a user UUID and product category and returns a list of product UUIDs recommended for that user from the associated Personalize campaign. The main purpose of this Lambda is to act as a sort of multiplexer by product category. Whenever a user visits the StockX home screen, their front-end client will send a request to our GraphQL resolver. This resolver will then query our Lambda, and upon receiving the list of product UUIDs, it will paint those products by fetching things like the product name, image, live market data like bids and asks, and other metadata, and will pass those along to the front-end client. Since StockX consistently has new products added without warning, this often means that our user interaction patterns can change from day to day or week to week. Therefore, a deployed personalized campaign can be out of date relatively quickly, and we want to train with new user interactions every day. Since we wanted to continue serving customers recommendations during the 6 to 8 hours it took for our longest solution version to train, we needed to come up with a strategy for retraining. So here's the first step of that strategy. We create a second dataset group. We then import the dataset, create the solution version, and campaign, and then test that that new campaign is successfully serving recommendations. We call this a heartbeat check. Upon a successful heartbeat check, we then switch which campaign the Lambda is pointed to by updating a Lambda environment variable via the Lambda SDK. Finally, we can initialize the deletion of the old dataset group and associated resources. If something goes wrong with this infrastructure creation process, like for example if our machine running this pipeline crashes, we can continue serving recommendations to users based on the old deployed campaign. This campaign switching process also gives us added flexibility while developing. For example, it allows us to seamlessly change the dataset schema and stand up a new campaign without needing to manually delete or modify any personalized resources. Campaign switching also makes cleaning up personalized infrastructure easier for us, since we have at most 2 dataset groups and their associated resources per product category to worry about. While we believe that using Amazon Personalize would deliver better results, we needed to evaluate it by performing an A/B test to prove the incremental gain. The first step of this was to create a testing document that outlined the A/B test parameters. We defined the test population as all of our web users and a test length of 2 weeks to ensure we received enough data to provide statistical significance. We also checked to ensure that there were no concurrently running A/B tests on the same user population, since this could confound the results. We then defined our key metrics. In this case, they were click-through rate and conversion. Defining these key metrics up front allowed us to make a more objective decision based on the A/B test results at the end. The next step was to create an experiment by defining an experiment flag and generating the control and variant user groups. The front-end clients were modified so that they sent this associated experiment flag with their user interactions data to our analytics warehouse. Once this was done, we started the experiment by rolling it out to a very small subset of users. We monitored traffic and dashboards to ensure that there was no bug or issue that we missed when deploying into lower environments. Once Recommended for You was confirmed to be working as intended on this subset of users, we ramped the experiment up to the total population and started the test officially. After 2 weeks, we performed an A/B test analysis on our clickstream data, and we used product page views as the counterfactual to avoid bias. And the A/B test results were very positive for this experiment. Our total user engagement on the homepage went up by 50%, so we were very excited by this. And here's what the Amazon Personalized powered Recommended for You experience looks like on StockX. This product row was launched as an A/B test on Singles Day of 2019 and was subsequently rolled out to all registered users in early 2020. Recommended for You shows users a row of products containing clickable product tiles with the product image, product name, lowest ask price, and last sale price. You will see this product row on the home screen of any of our front-end clients if you are a registered user and logged in. Recommended for You is currently the most interacted with product row on our home screen, despite being positioned below 2 other rows of products. So the lesson we learned here is that users like personalization, And the personalized product rows can easily outperform static or unpersonalized product rows. The user homepage was just the first place we utilized our personalized campaigns, but once you have a live personalized campaign, it can be easily added to other points in the user's journey. For example, you could add a post-purchase email, add it to the search or browse page, or even the product page itself. StockX is currently working on personalized-based emails for users in the near future. And here are some conclusions from our work on Recommended for You. Build to scale. We needed to select technologies that could easily scale to our traffic patterns. This made Amazon Personalize and AWS Lambdas good choices for us. Automate as much as possible. Machine learning engineering is hard enough as is, so automate the data ingestion, the infrastructure creation, and the evaluation as much as you can. The job isn't done once you have a trained model. As you saw earlier, there were many steps between recommending product UUIDs from a personalized campaign and showing Recommended for You to the user on the front end. Measuring the impact of your feature is necessary. Without an A/B test or other online evaluation method, we would have no way of knowing if Recommended for You was actually increasing user engagement. And it turns out from our A/B tests that our users do like personalization. And one theory behind why they liked Recommended for You so much is that our old home screen was more aimed towards our power users, which were a small portion of our total user population. And when these smaller users saw Recommended for You, they may have felt more included and represented, and therefore more likely to stick around and interact with our platform. The success of Recommended for You has encouraged a larger machine learning investment at StockX. Currently, personalization is even more important as we expand into other features like recently viewed products and other product rows we're currently working on. This success has paved the way for more machine learning and more personalization at StockX. The machine learning team at StockX consists of me, Blaine Dietrich, Nick Roberts, Jason Prasad, and Sam Bean, and we are hiring. So for more information about how we made the Recommended for You experience, you can check out our AWS blog post below. Thank you. And now I will pass the presentation back to James.
Thank you, Blaine. Before ending this session, I wanted to leave you with a few links to some additional resources. Of course, there's the StockX Personalized blog post that Blaine just mentioned. We also frequently publish blog posts that go into detail on new features, customer examples, and integration patterns. The Personalized developer documentation includes detailed information on how to use personalized features and the Personalize API. And since sometimes it's helpful to see sample code on how to implement a feature or build an integration, we have several examples on GitHub that will walk you through a feature or deploying a reference architecture. AWS is constantly adding enhancements and features to Personalize, so checking back on these resources is a great way to stay current with the service. In this session, we focus on Amazon Personalize as a way to quickly build a powerful recommendation system into your application using a fully managed service. If you prefer to build your own algorithms and models, Amazon SageMaker allows you to build, train, and deploy your own models also on AWS. Thank you for watching this session, and I hope we gave you a better idea of how Amazon Personalize can be put to work in your application. Your feedback is invaluable in shaping sessions like this, so we'd appreciate if you completed the session survey. Thanks again.